that the word depression is a very loaded word because the moment people hear the word depression, they think, oh no, that's bad. But in the case of neuroplasticity, long-term depression is simply a change in the connections between neurons and the excitability between neurons that in many ways can be excellent for learning things, in particular motor skills. And we'll get into this in more detail in a little bit, but it turns out that a lot of our ability to get better at some sort of motor skill involves this thing that we call long-term depression. And that's because much of what is happening when we learn a new motor skill is that we are depressing or suppressing specific actions in order to generate a very specific coordinated action. Some of the best examples of long-term depression can actually be borrowed from developmental plasticity. So for instance, if you've ever sat across from an infant who is trying to eat their meal, so imagine a 1.5-year-old or a 2-year-old trying to eat some noodles or some soup or any kind of baby suitable food with a spoon, and they're holding the spoon or they're trying to hold the spoon, what you'll notice is that their motor movements are terribly uncoordinated. They often will take that spoon to their cheek or to their eye or to their head. We've all seen these very amusing photos of babies with bowls of food on their head or with food all over their face or just everywhere. It appears that they're basically getting the food everywhere except where it's supposed to go, which is in their mouth. And that's because their motor movements are not very well coordinated at that age. And they're not very well coordinated, not because they lack sufficient numbers of neural connections, synapses between neurons, but rather because they have too many connections between too many different neurons. The neural circuits that control very dedicated, coordinated movement are not there yet. Instead, too many neurons are connected to too many other neurons, and so they can't generate the precise movements that are required in order to get that spoon to their mouth. Now, over time, they get better at moving the utensil to their mouth, such that hopefully by about age 5 or 6, they are eating, in a relatively cleaner way. And hopefully by the time they're 10 or 11 or 12, they're getting the food into their mouth and not all over their face. The younger the person, the more uncoordinated their movement of utensils. And as they get older, the more coordinated. Now, of course, in people that are very old, they have challenges moving objects and their limbs in very smooth ways. And that has to do with a topic that we'll get into when we talk about age-related cognitive decline and motor-related dementias. But for sake of today's discussion, if you just want to think about what happens with long-term depression and the development of a motor skill, both as a baby, as an adolescent, and as an adult, when you're trying to learn a new motor skill, is that you are eliminating incorrect movements. And when you are eliminating incorrect movements to arrive at only the correct movements in a very reflexive and repeated way. So think your golf swing, your tennis serve, think serving a volleyball, think a child learning to crawl and then walk, think a child learning to eat with utensils in the example I gave before. What's happening in all of those cases is that, yes, certain connections in the brain are being strengthened or what we call potentiated. They are undergoing long-term potentiation, the so-called quote-unquote fire together, wire together mantra that was popularized by the great neurobiologist, Dr. Carla Schatz, my colleague at Stanford. But in addition to that, long-term depression, the quieting or the silencing of specific synapses, that is connections between neurons, is absolutely critical for motor skill learning. So we have LTP, long-term potentiation, and LTD, long-term depression, is every bit as important as LTP, long-term potentiation, for getting better at some sort of motor skill and indeed at getting better at some sort of cognitive skill. Now, as we hear this should be intuitive to all of us. If you look at somebody's attempt to learn a particular dance step or at somebody's attempt to do a tennis serve the first time, it's all over the place. Now, it's not perhaps all over the place in that they're doing a jumping jack while trying to serve the tennis ball, but they're generally arcing the racket too widely on one trial, and then they're arcing it too close to their body on the next trial. So if we were to draw a line over each one of those trials, we would see that there were lines everywhere over time. Whereas once they, quote unquote, perfect the tennis serve, it's going to be line, drawn directly over line, drawn directly over line, meaning the arc of that tennis serve is going to be very restricted. And that, without question, has reflected the removal or the quieting of particular synapses, connections between neurons in the brain and body, to allow that very narrow, coordinated, and directed movement. The same is true for learning anything in the cognitive domain, meaning if you are to learn a language, It is not, of course, the case that you know every word in that language and then you simply remove certain words and arrive at the correct sentence structure that you're trying to achieve. But rather, you have to suppress your native language. Or if you're a young child, you have to suppress the generation of just kind of random babbling sounds. Turns out babbling isn't random at all. But the point is that you have to suppress the enunciation of particular sounds and direct the pronunciation of other sounds in order to generate that new language or your ability to speak at all. Okay, so we can really think about neuroplasticity as both a building up process in which you increase connection, so-called long-term potentiation, and a sculpting down or a removal of connections process that we're going to call long-term depression.